Okay, given that x and y are sets, we're taught to simplify y union x intersection y. If we're going to simplify this, write it y union, and that is x intersection y. We're going to use the distributive property here. Using the distributive property, and the property states that we're supposed to get the set outside, you distribute it inside the bracket. So to do that, this is going to be y union x, and that is intersection, you go back, which is y union y. When you do that, this is going to be, of course, y union x intersection y. Now, from here, I want to show you this information using the Venn diagram. So, using the Venn diagram, this is what you're going to have. So, this is x, y, and there we have x, y. Here, I'm going to have the final one. Here, we have, we're going to show this information in the Venn diagram, which is y union x. Also show y there. So to show this information here, y union x in the Venn diagram is going to be the shading of everything there. This is y union x. Y union x will look something like this. That is going to be the shading. What about y? Y is going to be the entire shading in y, or the entire space in y. That is going to be y. Now, we're looking for y union x intersection y. So when you look at these two here, for you to find the intersection of the two, you need to come up with the common parts that are shaded in both diagrams. So in this case, this part here is shaded, also it is shaded there. This part is shaded, also it is shaded there. So when you look at this, you know that this part is shaded and that part is also shaded. If this part is shaded and that part is shaded, we're going to shade this. What we have shaded here is y union x intersection y, which is just y. So in this case, if we're simplifying this, when you reach this stage, this is the same as saying y. So we have simplified this, which is y union x intersection y is the same as y, by using this information that we have here.